In this video tutorial, we're going to cover aspect in DEM, producing aspect within ArcGIS. And we have 8 steps that we're going to work through. So the first was we're just going to take a look at our working directory, make sure that we have a file path established. Understand the concept of aspect, so we'll take a look at what it does. Our path tool, the tools, so this is a surface tool aspect. We're going to pick a method, geodesic versus a z-factor. We're going to output our measurements based on a compass orientation, or this is 360 degrees essentially, which I'll explain. We're also going to introduce what's called reclass or reclassification. And the reason that we want to reclass something we'll explain in a second. We're going to derive a percent of the reclass values, so we know of the full data set, what's the percentage of our particular reclass, and then we'll express that in the legend. Okay, so about 8 steps here. So to get started, let's go ahead and just take a look at our drive. So here I have a folder for my input raster, and then I also have exports. So in this case I have a slope and a hill shade that I've already accomplished, and I'm going to be adding in aspect here in a moment. Okay, and then I have some MXDs set up, and I have aspects set up currently. That's what I'm working in. Go into GIS here. We can see that I have hill shade and I have the output SRTM. So I'm just going to go ahead and click on that. And I just want to go into the toolbox itself, so Arc Toolbox, and then I'm going to go down into Spatial Analyst Tools. After Spatial Analyst Tools, I want to be in Surface, and Aspect is the first one. So I click on Aspect, and I'm going to input my raster. This is going to be the DEM values. I'm going to output the raster to my output location, which is called Surface Exports. In this case, I'm just going to say Aspect. And I have 2 methods that I can choose. So the planar method, if I do planar, it's going to just run the tool. I could also do a geodesic method. So if I click on geodesic, it just wants to know what the Z unit is going to be. So that's its warning here. So the input data set doesn't have a vertical unit. Click for more detailed information. It actually does have a vertical unit, it just doesn't understand it yet. So if we go into our Z unit and activate it and say yard, we know it's not yard, so we need to make sure that we're picking it a meter because it's a SRTM 30 meter product. Then I can run this. And I'll just go ahead and say OK. Now what's happening is it's going through each cell in our input raster, and it's trying to it is determining what's the direction, what's the orientation of that particular cell relative to the other cells. Okay, so it's a calculation that is unlike slope, where it's looking at change in terms of elevation value, and it's instead taking a look at how the cell is related to other cells around it in terms of orientation on a 360 degree compass essentially. So let's go ahead and run this and say OK. And as it does this, it's going to produce a class product back to us that is always going to be divided into these classes. And it's giving a categorical name to each class. So we can see if it's a flat area, and there are a few flat areas in this particular scene, it's just going to call it flat. So that's something that's basically a -1. But as soon as we go into any cell value that aspect creates that's from 0 to 360, it's going to deem that a certain direction. So we can see north is basically 0 to 22.5, and it's also 337.5 to 360. So this is really helpful to understanding, say we were actually hiking this terrain, or we were somehow situated in this particular location, we could understand the direction of certain slopes or certain terrain relative to this product. We can also reclass this so that we get back just one direction. So we might want to know what's all north facing within this particular scene, or what's all south facing. And that might be part of a suitability analysis. Part of the suitability might be, I need all south facing terrain for a particular spatial problem. And to isolate that particular value within the larger values of the product, we have to use a tool called reclassify or reclassification. And with reclassify, that's found in Spatial Analyst Tools, and it's under the reclass box. So we can see it down here, Spatial Analyst Tools, reclass. And remember, to enact any of these Spatial Analyst tools, we need to make sure under extensions, we actually have Spatial Analyst turned on. Okay, so I'm going to go into reclass, and what I'm going to do for this demonstration is just reclass all north pixels. So when I get back my reclass, it's just going to feature those cells that fall within a north orientation, and those are these red cells. We can kind of see some of these reds. So we're going to go into reclass, and then we're going to go into reclassify. There's several different ways to reclass a roster, but we're going to do it the manual way through reclassification, reclassify. So what we do here is we input the roster. Okay, that's the aspect roster, not the original DEM, the aspect. Those are the values that we want to reclass. And we can see that we have old values, and it's just going to see our class breaks currently. So old values, if you want to change these old values into different classes, you would go into properties and symbolize based on the classification scheme that you're interested in. However, we see that north is already classed separately here, so we can go in and pick out our old values as north and get rid of our other values that are not north. So one way that we can get rid of things is use the new value of no data. So in this case, no data is going to equal everything except north. So we can see there's two places where north shows up. So north shows up at 337.5 to 360. So this particular cell I'm going to deem as a 1. Okay, I'm going to produce a 1 no data product. So that gets a 1. And then if I go up to north at 0 to 22, I'm going to give that a 1 also. So those two are going to be my 1s that come back. Everything else, including the flat areas, is going to be no data. So it's capital N, O, then capital D, A, T, A. It needs to be expressed in that format, no data. And what I'm going to do now, this is a little bit tedious, is go through each one of the new values and change it to no data. Okay, so it's literally going to essentially erase these pixels, or at least class them into no data. Okay, so I have two options here, 1s versus no data. 1s for north, no data for everything else. And I'm going to output my roster to my surface exports, and I'm going to call that, in this case, let's call it aspect north. So it's going to run, and I'll close this, and then I need to get rid of my original aspect, and then we can see that these particular values that I have just developed, let's change this to another color that's going to show up a little bit more, maybe a reddish color. So these values all represent the north-facing pixel areas within my scene here. Now, what I might want to also do is determine what percentage of this particular extent are north-facing pixels. And the way that we can do that is we go back to the original aspect and go to Properties. And under Properties, look at Classify and look at the classification statistics. And we can see a count, standard deviation, sum, mean, minimum, maximum. What we're interested in here is the count. And so this is the count of every cell within the original DEM scene. And what we need to do is we need to jot this down. So I'm just going to open up my text document here. And I'm going to jot this down. So let's go into 101,936,94. Make sure you get this right. Okay, so that's my total number of cells. And once I know that, I'm going to go into aspect north, and I'm going to open up the attribute table, and I can see that I have a count currently of all the cells that are north, that are in aspect north. So that's good. I have that. I'm just going to add in a new column now. So I'm just going to say add field. And this is going to be a long integer, because remember, that's an integer number that I just had. And I'll call this total count. And say OK. And I just need to go back into my sheet here, copy this, Control C, and I'll go back into total count. And under total count now, I'm just going to use the field calculator, and I'm going to say total count U equal, paste in that number, and say OK. Okay, so now I have a count and a total count. And to get a percentage, I'm just going to put in a formula for a new field called PCT for percent north. And this is going to be a double. Okay, it's not going to be an integer. I'll say OK. And I'll go to field calculator. And here, the calculation is going to be the count divided by the total count times 100. Okay, so that's going to give me a percentage now. And I'll say OK. And it gives me a percentage of 12.182, basically 12%. Okay, so now I know of the aspect north that 12% of the scene is based on a northward orientation. Okay, so north is not particularly dominant in the scene. And it looks to me like east, which is the yellow, north, east, and east might be more dominant. Okay, so what we're going to do now is we're going to go ahead and develop this now as a visual product. So I'm going to click off my DEM values and just overlay my northward orientation onto the hillshade. I might make this a little bit transparent. So I go into display, and the transparency here can be, let's make it 40% transparent. Okay. And then I'm going to make a legend for this. So if I wanted to have just aspect alone over a hillshade like this, I would then go into insert a legend. And I just want to have aspect north on it. So click on aspect north and say next. And I might just call this aspect. And then I might have it in parentheses north. And say, okay. And what I might want to do here, instead of saying 1, is just say, I could say north or north orientation. I've already said north before, so I could say, trying to make this active here. It's not allowing me to activate it. Let me see if I can do it here. I'll just pause the video and see if I need to get the 1 to be active. All right, I just had to fool with that for a second to get into the box, and now it's once again not available. There it goes. Okay, so here let's go ahead and say call this north, and then I would want to call it 12%. And let's do this. Let's go back to the actual title and just call it aspect instead of being redundant north twice. So I might do something like this and say apply. Okay. So something like that works. So we know that this map is aspect math, and we're saying that these pinkish pixels are north at 12%. So that's kind of what we wanted to get to. For understanding what aspect is about, there's some online documentation that describes in detail what it actually is. So I could bring that sheet over real quickly and just go over it real quickly. So here on aspect, we're talking about 360 degrees of orientation. In effect, it's a compass, and aspect's always going to result in a classed roster based on these particular breaks. And there's a couple references in our assignment sheet that goes over what this actually is. Okay, so there's aspect direction, and trying to find the actual link to that particular document. I'll make sure that it's in so you understand what the definition of aspect is. Here it is. It's a short definition of aspect, so make sure that you read over that before you actually process the tool. And again, it's a focal operation, very much like slope is a focal operation. So make sure that you understand what a focal operation is, so you kind of understand what's happening behind the scenes in terms of aspect. And the definition here, let's just repeat this through. So aspect identifies the downslope direction of the maximum rate of change in a value from each cell to its neighbors. Okay, so it's looking at both the downward slope, but also the direction of that particular slope, and this thus derives the aspect.